Good morning, friends. My name is Kiran, and my branch is Mechanical Engineering, and my subject is Manufacturing Process. Here we can see that my topic is Resistance Spot Welding Optimization. Here, through the topic only, we can say that what are the spot welding and resistance spot welding observations. And here we can observe that introduction to resistance spot welding. Resistance spot welding, we can in short form we can call it as RSW, is a process that joins metal sheet by applying heat generated through electrical resistance. Here RSW is nothing but it's a joining the metal. It's only we need to understand that joining the metal or joining the metal sheet with the help of heat generate electric resistance. With the help of heat generation, it can join the metals. That is the main definition and main theme of this RSW, and it is widely used in automotive and aerospace and manufacturing industry due to its speed and efficiency. Actually, this was mainly used in automotive and aerospace because of the at the time there is morely which can we use the things like joining the metals. At that time we can use RSW, and optimizing RSW parameter is essential to ensure strong, reliable weld while minimizing cost and defects. This was the one thing essential because of while we are doing the RSW, we need to minimizing the cost and defense. I mean, sorry, not defense, it's a defects and basic principles of resistance spot welding. RSW involves passing a high current throughout overlapping metal sheets to generate heat at the constant point. Contact point is nothing but at the help of contact point we have to we can observe that RSW. Here the main thing is overlapping the metal, which is not necessary because of the heat cannot generate through the contact point. And the next thing is the process released on applying the sufficient force to forge the molten material into a solid and fuse and join. After the process is applying, we need to apply a little bit of force for the forging. Molten materials is involved in it can converted into solid and fused and joined. And proper control of current and time and pressure and electrode conditions are crucial for quality welds. In this welding, we need to things like current and time and pressure. This for the things. At the same time, we need also electrode. Here we can see that the schematic of resistance spot welding. There is a force applying of the electrodes. At the same time, two electrodes are there is a two which we need to join the materials we are put between the two electrodes, and we can press the force which can be joined the metal sheet by applying the heat, or we can apply the resistance of electricity. And key parameters in RSW optimization is welding current determines the heat input and influence weld size and strength. This was the one key parameter. And other thing is electrode force impact weld penetration and consistency. Welding time affects the thermal cycle and cooling rate, influencing weld quality and defect formation. These are the key parameter in RSW. And common defects in RSW and their causes. What are the defects in RSW? Lack of fusion occurs when insufficient heat prevent proper bonding between sheets. Main defect is the thing while we are applying the heat, we need to apply sufficient of heat between the metals. Because of we can apply if we can apply insufficient of heat means it can the it can't be joined proper and it can form a defect. That's the one defect. And explosion results from excessive heat causing molten metal to be expelled from the weld nutted, because if there is we can apply overheated means also it will be problem. And interfacial cracks and porosity are often to due proper parameter setting or contamination. This was one more slide we can observe here. Techniques for parameter optimization. What are the techniques or for this RSW thing? We can see RSW. I mean not RSW, RSW. Here we can see RSM. RSM is nothing but response surface methodology, can be used to model and optimize welding parameter statically. Here RSM is nothing but it have the method and it will give you the path to how can we join the metals without any defects. And here one method is Tagichi methods helps identify the most influential factors or reduce variability. And finite element analysis allows simulation of thermal and mechanical behavior for process improvement. Now, electrodes and their role in optimization. Electrode material and geometric direct affect heat transfer, durability, and weld quality. This was the role in optimization of electrode, and regular maintenance and proper alignment are necessary to prevent electrode wear and ensure the consistent result. This is also one of the role. And advanced electrode designs can improve heat distribution and reduce the defect. Because of the through the reducing the defect, we can say either the electrode was the improved heat distributions or not. And quality control and testing method. Non-destructive testing techniques such as ultrasonic and X-ray inspection and verify well integrated. This was the non-destructive techniques. And destructive techniques are including peel and shear test, assess the strength and the failure mode of the weld. This was the destructive test. And continuous monitoring of process parameters, ensuring consistency and early detection of issues. Case studies and industry applications. Automotive manufacturers have achieved reduced cycling time and improved weld strength thought parameter optimization. Aerospace components benefit from precise control of RSW to meet safety and performance standard. And customized solutions in manufacturing lines help adapt RSW process to specify material combination and thickness. And challenges and future tenses. Managing variability in materials and environment conditions remains a challenge for consistent quality. Integrating of LOT means nothing but Internet of Things, and real-time data analytic offer opportunities for smarter process control. And one more thing is development of new electromaterials and advanced sensor will enhance process reliability and efficiency. At the last, we can see conclusion and summary. Resistance spot welding optimization involves careful control of process parameters and electrode conditions and quality measures. And combining statically and computationally tools can significantly improve weld quality and process stability. Ongoing research and technology advancement continues to extend the capability and applications of RSW. Once we can recall what we learned here, here the topic is resistance spot welding optimization. Introduction of resistance spot welding is nothing but it is a process of joining metal by applying the heat, or we can generate the heat between the two metals and we can join the metal. That was the main thing of resistance spot welding. And basic principle of this was is only one basic is we need to apply the sufficient of force and molten material into a solid. We need to change the molten material into solid. Because of while we are applying the sufficient force, we can observe that the force of the molten material into the solid. That was the one principle. And key parameter means nothing but there is mainly heat input is insufficient means it will it is the type of a defect and it can't be impact on the penetration. That was one parameter. And common defect is mainly we can observe in causing the molten material to be explode. Because of the while we are improving, or we need to join the two metals, we need to give proper of the force, I mean force at the same time of heat to prevent the defects. And techniques for parameter optimization is RSM. It's nothing but response surface methodology. This was one of the technique. This technique is helpful for the reduce the variability and most influence. And one method also he said that the method is Taguchi method helps identify the most influence. Electrodes and their role in optimization. In optimization of role, what are the electrode main observations? Here the electrode main observation means nothing but it is have durability and heat transform. This was two things very important. And one more thing is it can distribute the heat of reduce the defect. It will reduce the defect through the applying the heat distribution. And quality control and testing method. Here there is two destructives as nothing but destructive testing and non-destructive. Destructive means nothing but it have the shearing test and strength and fail of modes well. Non-destructive are two types like ultrasonic and X-rays. And case studies and industry applications. mainly automotive manufacturing are the achieved of reduced cycle time. Because of the in automotive manufacturing there is different welding and different type of weldings are observed, and that was the one applications we can observe. In aerospace also, that was the one precious method we use, like RSW method. That was the one benefit for the aerospace. Challenges are only one thing we can see, while we are using this method, we need to cooperate, or we need to handle the temperature, and because of the environment condition we need to understand. At the same time, we can have the time, we can have the things like internet of things, real time data analytic. This also we need to remember at the time. Conclusions, we can see that resistance spot welding it's involves in carefully because of the parameters of electrodes, or they are electric circuit. That's why we need to careful. That was the one conclusion. Thank you.